Okay, in this module, we are going to be a little bit more concrete about the risks behind the critical materials. I guess the first one you are thinking about is the CO2. And you are right. Let's have a look at this graph, where we have the different sources of CO2 sector by sector. Have a look here. You see that the metal industry, if you take into account the steel plus the metal industry, is about 7.9 to 8% of the CO2 emission of the whole humanity. That means that 1 kilo of CO2 every 12 come from the metal production. The metals that is all around us. The steel is everywhere and the copper is everywhere. So this is 8% of the CO2 emission of the humanity. Is it a lot? Let's compare with a sector that is negatively on the spotlight due to their CO2 emission. Understood, I'm speaking about aviation. Aviation is about 2%, means 4 times less than the metal industry. So yes, metal industry is highly CO2 intensive. But we saw before in the introduction that those metals are needed for the green transition. So here is the paradigm. But all the metals are not equal. Steel, you see, is the main contributor to CO2 with 7.2%. But let's have a look now per unit of mass to this new graph. Surprisingly, you can see here, steel is actually the greenest metal per unit of mass with 2 kilograms of CO2 per kilo. Yes, the issue is that we produce something like 2 billion tons of iron, the most produced metal in the world. And on the other side of the spectra, you can see that the precious metals that some people are wearing as jewels, like gold, like platinum, their emission is few tenths of tons of CO2 per kilo. That's absolutely insane. This is huge. Just to give you some picture, 1 kilogram of gold or platinum is about 5 centiliters. Yes, the density of those metals is 20. So you can make the calculation. 1 kilo of gold will be 5 centiliters. This is a cup of coffee, or this is a shot of that you can have in a bar. This simple volume of metal emits about 50 tons of CO2. And 50 tons of CO2, it's equivalent to traveling 500,000 kilometers by airplane. That's 12 times around the globe. So this is absolutely huge. So not all the metals are equal, but these metals are produced in much smaller quantity. So now let's think about the production, right? When we speak about the risk of metals, the second risk that comes to your mind is like, do we have enough? Are we producing enough for our plan for the green and digital transition? So as I was saying before, the production of steel is about 2 billion tons. This is really huge. Want to compare the second metals will be aluminum, which will be from about 40 to 50 million tons. So this is much smaller amount. And then if we go to the rarer element, we have platinum that is produced at 200 tons. So 200 tons, it's 10 cubic meters. That's very small. That would be here a cube that would be a bit more than 2 meter by 2 meter by 2 meter. That would just fit here near me. The whole world production would fit here. There are even rarer metals like rhenium or like osmium that is only produced by about a ton. So 1 ton of osmium would just be about that size. So this is very huge, and we have to take it into account when we design a product for the green and digital transition, because when we speak energy or when we speak a digital economy, we speak about world application. That means the demand will be huge. So this is the second point to take into account. When we speak also about metal, we speak about mine. And mine, as I was saying in the introduction, has a very big impact for the community. A mine will consume a lot of energy. A mine will consume a lot of water. a mine will employ a lot of people, and a mine will be using a lot of chemicals. So these impacts can be positive or negative. That maybe surprises you, right? When we say a lot of energy, it can be negative. Yes, if you use fossils, this is going to be negative because the amount of energy you will need for extracting the rock, for processing them, will be turned into CO2. This is negative. However, in the very recent years, many mining companies are investing massively in the renewable energy, so to decrease the amount of CO2. And it has a positive impact on the community, because sometimes some countries have very highly CO2 intensive energy, but in the community near the mines, they have a greener mix, because the mine has invested for themselves indeed, but also sharing with the community the green energy. So you see here, this impact can be positive or negative. It depends on the practice. Same with the water. Some mines can be located in a desert. So who says desert? This means small amount of water. But the mine is a huge consumer of water. So this might be subject to conflict that has to be solved. Same with the social aspect. A mine properly made can be a source of employment, can be a source of infrastructure, which is positive. But it can be, if badly made, a source for terrible conflicts. So here you have to take into account, and you have to understand that not all the metals are equal, not all the mines are equal. Some actors are properly behaving, and some are absolutely not properly behaving. So you have to just basically investigate what are the practices of the producers, because they are very different from one to another. The last risk that we can speak about is the geopolitics. You all heard about it, because on the newspaper we now speak more and more about metals as a diplomatic tool. You see that the production of metal is very concentrated within several countries. China is the #1 actor in the mining industry. Australia is a big actor, Brazil, Russia, USA, Canada, Indonesia. And South Africa, these are the main actors. They don't necessarily agree on everything. They have sometimes sanctions on one another. They may have some trade wars between each other. And metals, as a very critical commodity, might be used for sanctioning another country, or for pressurizing on the policy of another country. So this is not something you should obliterate or ignore. Everybody knows that there has been wars for commodity. There has been in the past centuries, there has been last century or in the early 20th century for oil, and there might be for the critical metals. So this is something the citizens should be careful with, and this is something where innovation can help us to avoid such the dramas.